All right, guys, here's the start to section 8.2. Now 8.2 is all about special right triangles. So when we're talking about special right triangles, we're talking about 30, 60, 90 triangles, and we're talking about 45, 45, 90 triangles, okay? And as we'll learn in this chapter, each side length can be predicted if you only have one of these other sides. So there's kind of sort of formula, but we'll go through it. But what I want to do first is just kind of go over how to do simple operations with radicals, because we will use this a lot. So I'll do the first one. So it says 8 equals x squared of 2. So if we want to get x by itself, we would divide both sides by square root of 2. Okay, and what I'm left with is x equals 8 over square root of 2. Now you guys know we can't have a square root in the denominator, so we're going to multiply it by square root of 2 over square root of 2. Square root of 2 over square root of 2 is just 1, so it's perfectly legal to multiply something by 1. What we're left with is 8 square root of 2 over square root of 2 times square root of 2 is square root of 4, which reduces to 8 square root of 2 over square root of 4, guys, is just 2. And then if I notice, 8 over 2 goes to 4 over 1, so this is just 4 square root of 2. Okay, I want you to go ahead and do B and C on your own, and then we will go over them. All right, so B, the first thing I did is I changed 1.5 into 3 halves, because that's what that's what it is as a fraction. And then divide by square root of 3. So you get 3 halves over square root of 3. And remember, when we do this, we can just put these two denominators together to where you'd get 3 over 2 times square root of 3. Okay, and then we would simplify this, bring the square root up to the top, multiply square root of 3 over square root of 3, and simplify it, and you would get square root of 3 over 2. C is probably the easiest one on here, because all you'd have to do is divide by 2, and then simplify. 8 over 2 goes to 4 over 1, or just 4, so you're just left with 4 square root of 7. All right, so I want you to go through and do these. I'll do the first one together, but what I want you to do is just go through and use Pythagorean theorem like we've already learned, and go through and find all the side lengths. We'll do this one here first, just so I can show you. If this is a 45, 45, 90 triangle, we should know that if we have two congruent angles, we have two congruent sides, so this would be 5. Okay, and then to apply the Pythagorean theorem, leg squared plus leg squared equals hypotenuse squared. 5 squared plus 5 squared equals y squared. 25 plus 25 is y squared. So 50 is y squared. And then if we break 50 down, well, 5 goes into 50 10 times. 5 goes into 10 twice. 2 goes into 2 once when we're done. So I'm left with y equals 5 square root of 2. Okay, so 5 square root of 2 goes here. Okay, so go ahead and do these 3. By the time you get to this last one, you may have come up with a formula, but if you don't, I want you to look at your answers and find a formula. It should be something that's fairly obvious. All right, so as you go through this, we had 5, 5, and 5 square root of 2 here. Over here we have 1, 1, and you should have gotten square root of 2, or I put 1 square root of 2. It's the same thing. Down here, if you do the Pythagorean theorem, you have 8, 8, and 8 square root of 2. And then over here you have 12, 12, and 12 square root of 2. So if you go over all of these, what you should notice is this square root of 2 on the hypotenuse. And then the first number on the hypotenuse is always the same as the leg. Okay? So hopefully you notice that. Okay, so if I wanted to make a conjecture, I could say on every 45, 45, 90 triangle, I could say that the legs are the same or are congruent, and the hypotenuse is the leg times the square root of 2. And that brings us to the 45, 45, 90 triangle theorem. Okay, now I do want to note this only works for 45, 45, 90 triangles. It doesn't work for anything else. And what it says is what we just found, is that each of the sides are the same, and then the hypotenuse is the side multiplied by the square root of 2. Okay, hypotenuse equals the leg times the square root of 2. And if we have one of these three sides, we can find the other two by using this. And we'll do a few examples here in a minute. All right, so let's do an example. Now, I want you to understand that this is a concept that's very, very easy to overcomplicate. And so if you do that, know it's normal. If you struggle at first, know that it's normal. But like I said, most people overcomplicate it. It's not that hard. It's just you try to think too hard about it. Okay, so the ones we just did were nice and easy, but not all of them are that easy. Okay, so here we have a 45, 45, 90 triangle, and the hypotenuse is just 10. This would be easy if it was 10 square root of 2, but it's just 10. Okay, so what I'm going to do is I'm going to totally ignore these other variables. And I'm just going to mark each of the sides like this theorem tells us. The legs are x, the hypotenuse is x square root of 2. So I'm going to say x, x, x square root of 2. Okay, so if I solve for x, I have all three of these sides. I can just plug it in and substitute it. But what I know is this side that is 10 also has to be equal to x square root of 2. Okay, so to solve for x, I'm going to say 10 equals x square root of 2. Okay, now it's back to our warm-up problem. So just divide both sides by square root of 2. Those go away, and I'm left with x equals 10 over square root of 2. I need to rationalize this, so multiply by square root of 2 over square root of 2. I get 10 square root of 2 over 2. One last thing, 10 over 2 simplifies to 5 over 1. So this is just 5 square root of 2 equals x. Okay, so x equals 5 square root of 2. So if this is 10, then this side has to be 5 square root of 2, and this side here has to be 5 square root of 2. Okay, and like we said, the hypotenuse is always the leg times the square root of 2. So just to double check ourselves, you can say 5 square root of 2 times the square root of 2, which would be 5 square root of 4. Square root of 4 is 2, so 5 times 2 is 10. And that's exactly what we had. All right, so here are a couple easy ones that I want you to do on your own. So I'm going to kind of help start you out, then I'm going to have you do the rest on their own. But what we want to do is we have a 45. This has to be 45 because this is 90. These two are the same, so we know they have to be 45, 45, 90. Okay, so what I'm going to do, just like I did before, I'm going to label the legs x, and the hypotenuse x square root of 2. Okay, x and x square root of 2. All right, so I want you to solve for x and then show all three sides of the triangle. All right, so on A, I know the leg is 8. So if one leg is 8, the other leg has to be 8. Once again, because we know we have two congruent angles, which tells me we have two congruent sides. And the hypotenuse is always the leg times square root of 2, so this is just 8 square root of 2. Okay, over here we didn't have the legs, but we had the hypotenuse is 5 square root of 2. But we also know the hypotenuse is the leg times square root of 2, which means our x has to equal 5, our leg has to equal 5. So both of these are 5. All right, now these two are a little more difficult. So I'm going to do D with you and then have you do C by yourself. But the first thing I want to do is I want to label this. So the side is x, x, and then the hypotenuse is always x times square root of 2. Okay, so the one side I have is the hypotenuse, which is 2 square root of 10. So I know that 2 square root of 10 has to equal x square root of 2. Okay, now I solve for x, divide by square root of 2, divide by square root of 2. I get 2 square root of 10 over square root of 2 equals x. Now there's a couple ways I can solve this, but the thing I see is that 10 and 2, I can break 10 apart. So I can say that 2 square root of 10 is the same thing as 2 times square root of 5 times square root of 2 over square root of 2. And the reason I did that is because square root of 2 and square root of 2 cancel. So this is just 2 square root of 5 equals x. Okay. Now after I've solved for x, I can substitute x in. Well, 2 square root of 5 for this leg, 2 square root of 5 for this leg. So we're done. Okay, I want you to go ahead and do C on your own, and then we'll go over it. Make sure you label all these correctly. This is x, and this is x square root of 2. All right, so when we do this, guys, x, and x square root of 2, I know my leg is 5 square root of 7, so this side over here is also 5 square root of 7. And my hypotenuse is the leg times square root of 2. Okay, well, we know my leg, or my x, is 5 square root of 7, so I'm going to substitute 5 square root of 7 in for x. So I get 5 square root of 7 times square root of 2 over 5 square root of 14. Okay, and that is my final answer.